Hello, this is Mrs. Huntley. This is Module 2, Lesson 1, Why Move Things Around. You should be on page 7 of your student workbook, and the essential question at the top of the page should be, how can objects be moved in the plane while preserving their size and shape? Now, I realize that you do not have the same drawings on your page that I have on mine, so I'm going to ask you to copy my drawings as best you can, and I'm going to read the directions, and then we'll go through what we're doing on this page. So the directions say, given two segments, AB and CD, which could be very far apart, how can we find out if they have the same length without measuring them individually? Do you think they have the same length? How could you check? And then the second part says, given angles AOB and A prime, O prime, B prime, how can we tell whether they have the same degree without measuring each angle individually? And then finally, if two lines, line L and L prime, are parallel and they are intersected by another line, how can we tell if the angles A and B, as shown, have the same degree when measured? So you're going to want to create your parallel lines and then cut them by a transversal and then label your angles. So go ahead and pause the video at this time and copy the drawings as best you can. When you're done with that, come on back. You'll notice here I've got a picture of like a street map. And this ESB stands for Empire State Building, and then we've got Broadway and 6th Avenue and 5th Avenue and a bunch of cross streets. And this is like a road map, and on the road map, well, I shouldn't say on the road map. In this unit, we're going to talk a lot about mapping. And looking at a road map helps us understand the idea of mapping. The idea of mapping is that one point in one area is represented in the same or corresponding corner or corresponding area of another figure. So there might be the Empire State Building is located at the intersection of 5th Avenue and West 33rd Street, it looks like. This box here, this blue box, is not the actual Empire State Building, but it's representing where the Empire State Building would be. So the point in space that the Empire State Building possesses is correlated to this point on my map. So when we talk about mapping, it's the idea of one point in one area is represented in a corresponding area in a different figure. Hopefully that makes sense. Okay, I'm going to, oops, I thought I turned the overhead on, but apparently I didn't, so I'm going to pause. Okay. Now the overhead is on. Hopefully you have your drawings already, and now you're going to take the transparency that you received in class today and your dry erase marker or your wet erase marker, whatever. We're going to take it and we are going to put it over our drawing, because again, the question is, how could we tell if they're the same size without measuring them directly? So I'm going to copy line segment AB, and then I'm going to move it. So that's the only one I'm going to copy. I'm going to move it on top of the other line segment. And my A is going to map to the C underneath it, and my B is going to map to the D underneath it. Do you see what I mean about mapping? So I moved it, and then they map to each other. And I can see that, yes, my two line segments are exactly the same length. I'm going to do the same thing with the angle measures. So I'm going to copy angle AOB as neatly as I can. And notice I didn't bother erasing that because I have enough space on my transparency. So I am going to move it around. I'm going to match up my vertices, my O, and then I'm going to turn it around until my legs match up. And I can see that these two angles, again, have the same angle measure because they meet right here. They map to each other. I realize that yours might not have worked out as perfectly as mine did because I asked you to copy it, or I asked you to draw it on your own. This last one should work out regardless of what our parallel lines look like, because there's certain angle relationships that you're going to learn all about in the next part of the unit that hold true for all parallel lines that are cut by a transversal. So I'm just going to slide this down and then turn it around, and I will see that angle A maps perfectly to angle B. And that's basically what we were doing on this page. So the idea that you had to draw in the shapes didn't really detract from it, but you kind of knew ahead of time that they were going to work out that way, and working with the transparency didn't prove that to us, that it will in other areas. So hopefully that was still something that was worthwhile for you. Now on the next page, page 8, I'm going to have you clear off your transparency, and then you're going to draw, you're going to copy, I should say, this image, the pre-image actually, because this is our original, the pre-image, and we're going to use words to describe how it moves. Our directions tell us describe intuitively what kind of transformation will be required to move the figure on the left to each of the figures 1 to 3 on the right. To help with this exercise, use a transparency to copy the figure on the left. Note, begin by moving the figure on the left to each of the locations 1, 2, and 3. So we're always going to go back to the original, the pre-image. So when I'm moving it to map to image 1, what am I doing? Just kind of sliding it up and to the right. But I have to know when to stop. Because if I say just up and to the right, I could be going up and to the right, you know, off the page or whatever. So up and to the right, I'm going to say up and to the right until the shaded part maps. The shaded part from the pre-image maps to the shaded part on the image. The pre-image is where we're starting. The image is where we're moving to. See if you're comfortable, go ahead and pause the video and see if you can figure out what kind of moves we're talking about to go from the pre-image to image 2. So go ahead and play around with it a little bit. When I look at this, I automatically think I need to match up my shaded parts. I need to map them on top of each other, and then I'm going to flip it over until the rounded parts match to each other. That's what I see right off the bat. Now I did know in class earlier today, some students said, well, no, you could match up the rounded parts and then flip it, which that would work as well. But this is definitely going to be a slide and a flip. So go back to the pre-image and see if you can figure out how to move to get onto the third image. Again, this one automatically, I thought, let's slide it over until the shaded parts match, and then turn until the rounded parts match. Again, some students corrected me and said, well, you could go until the rounded parts match and then turn it. That would work as well. Still, other students said, turn it a quarter turn and then slide it. Any of those would work as long as you know how to describe them. That's the whole idea, is being able to describe them. So let's go ahead and use some words to describe them. So to get from the original to number 1, so here's my pre-image, my original. To get to number 1, I slid the figure to the right and up until the circles matched and the shaded parts matched, or mapped. To get from the pre-image, the starting point, to number 2, I moved right until the flat shaded part mapped to each other, and then I flipped. And to get to the third one, to get from the pre-image to number 3, I moved right until the flat parts match up, and then I turned it around until the curved part matches. Or you could do move the pre-image right until the curved part matches, and then turn until the flat part matches. So this is an either or. You don't have to write both of those down. So the part at the bottom is that same exploratory challenge that we were doing at the very beginning. Given 2 segments, A and B, which could be very far apart, how can we find out if they have the same length without measuring them? We can take them, we can trace AB and move it on to CD. We move things around in the plane to see if they're congruent. And we're going to be defining all of the new vocabulary that I've been using throughout the lesson and that you've been hearing. And what's going to happen with this new vocabulary, I had people ask me today, so are we going to have a vocabulary test? And no, we're not going to have an actual vocabulary test, but what I want you to do is be comfortable with these words and be able to use them to describe what's happening. So if we have an assessment, and there's an assessment where you have to move something, I want you to be able to use this academic language to describe what you're doing. Now you notice in the vocabulary section, we have a column that says words, and the words are all given to you, a column that says definition, and I will help you with the definition, and then example. Some of the examples I'm going to give you, others I'm going to ask you to come up with, and then this other column. This one is one that you are solely responsible for. If English is not your first language, if you speak Spanish or Polish or Lithuanian or whatever language you speak at home, you could translate the definition into that language. You could draw a different picture. You could draw a hint that helps you perform whatever operation we're talking about. So this column is solely yours. You have sole discretion. And yes, it is assigned. You have to do it. Even though I'm not filling it in, you have to fill it in. So the first part of our vocabulary actually starts on page 3. And it's 2 words at the bottom, image and in the plane. An image, I know you heard me use the word image and pre-image, and we're going to go over both of those. Image is a point or shape that has been transformed, the result of a transformation. And I drew 2 triangles here. And I drew this line between point A here and A prime here. My pre-image is my before. This is where I started. This is where I moved it to. Okay, so my image is what I call it after I've moved it. My pre-image, pre means before, so that's going to be where it was before I moved it. In the plane, a plane is a flat surface that has no thickness and extends forever in all directions. Now I just drew what kind of looks like the transparency, because when I look at the transparency, I think if it was ginormous and it went in all directions, that would be kind of what a plane would look like, I would think. Some of you guys have worked in the Cartesian grid. That is also a plane. So, some of you are very familiar with what a plane is. Others have not heard the terminology, and this is the first time. If it's confusing to you, as we work with it, it should become more clear. A line. A line is a straight shape with arrows on both ends. It has no thickness, and it extends forever. And the example that I gave you is a line, and this particular line has 2 points on it. Now, not all lines necessarily will have 2 points on them. This one does, and if I were to use notation to talk about this line, I could say it's A, B, and then I'd put a line over it, and that would be my line notation. Mapping, I kind of went over mapping already, but it matches each point of one set with another point in another place. Think of a road map. So again, I just kind of drew a rudimentary road map here, and I used some streets that we're more familiar with, like Raymond Street or Market, First Avenue, Second Avenue, and again, this point is not literally the intersection of Raymond and Second Avenue here, but it represents it, and this is a point on my map that represents that actual intersection out in the road. Preserves distance is another word that we're going to identify, or another words concept we're going to identify here. Preserving distance means the length between 2 points in the pre-image will be the same as the corresponding points in the image. So if I say my distance between A and B here is 1 centimeter, it's going to be 1 centimeter here too. Okay? So it preserves that distance. Quadrilateral. Quad means 4, lateral means sides, so a quadrilateral is a 4-sided polygon. Now there are many to choose from. I gave you a rectangle, a square, a trapezoid, and a rhombus. You can choose to put them all, or you can choose to put one, or you could choose something completely different. That is up to you. Rigid motion. Rigid motion are examples of transformations that preserve the distance between points. So the size and shape are the same after it's moved. All of the motions, all of the transformations that we're going to be doing in Module 2 are going to be rigid motions. Now, I don't have an actual drawing for you, but as far as an example goes, think about if you are moving the furniture in your living room or in your bedroom or something like that. You are not changing the shape of the room, nor are you changing the shape of your furniture. You're just moving it from one area to the other, and that's what all of the rigid motion transformations do. So you can make some notes about that there. You can draw some pictures. You can use a different example if you want to. That's up to you. A segment. Remember when we drew the line? So a segment is a part of a line. We drew our line and we had A and B on it. The segment here would be segment AB. And again, my notation for that would be AB. And instead of drawing the line over it, I would just draw the segment over it. And we're going to identify transformation. A transformation is a change in the position, orientation, or size of a figure. Now don't let this last part throw you. When we're talking about changing the size of a figure, that's actually coming in the next module. That's something called a dilation, and it's not something we're going to be concerned about in this module, but know that there are transformations that will change the size of a figure. And again, with this one, I don't have an actual example, but let's go ahead and we can say the transformations that we're going to be doing in this module are translations. Sometimes we call that a slide. Rotations. That might be a turn. Or reflections. And that would be a flip. That's probably what you called them in elementary school. Okay. So, that's actually the last vocabulary for this lesson. So if you need to go back and review anything, please by all means do that. And just to summarize and recap here. So let me find my summary. You can use your transparency to represent a plane and move figures in the plane. A transformation of a shape in the plane is one that assigns each point of the original, the pre-image, to one unique point denoted by a prime sign or showing that it is moved in some way. All of the transformations that we're going to be dealing with in this module are going to be distance-preserving rigid motions, meaning that the distance between points in the pre-image is going to be the same as the distance between the corresponding points in the image after it's moved. I will see you tomorrow. Have a good night.